Alright, this is your introduction to physics. Now, a couple of basics. Physics is the study of matter, motion, and energy. As you already know, we've been talking about motion and energy. A physicist is a scientist that studies these subjects. So they study matter, motion, and energy. Sir Isaac Newton was one of the best-known physicists. He was born in 1642. He was an English scientist and mathematician that discovered the laws of light, color, motion, and gravity. Now, this is what we call four squares. If you notice, there's four squares. Actually, a couple of them are rectangles, but we're going to call it four squares anyway. You're going to have a box for word. You're going to have a box for definition, a box for a picture, and then a box for a formula, if there is a formula that goes with it. Alright, let's go ahead and get started. Motion is your first word. The definition of motion is an object's change in position relative to a reference point over a period of time. Now, you're going to draw a picture. You can draw whatever picture you want to. This is just an example of motion. Remember, draw something that's going to help you remember what motion actually is. Now, formula, there's not a formula for motion. So, we'll put NA, which means not applicable. Basically, it means there's not one. Alright, our next word is reference point. In the definition for motion, we have the word reference point. So, it's important that you know what that is. A reference point is moving or non-moving objects on Earth's surface in which we can compare to determine motion. So, you're going to draw a picture. If you notice the trees on the picture on the right and the mountains on the pictures on the left, those are standing still, and that's what allows you to see that the skiers are actually in motion. Now, this one doesn't have a formula either, so just write NA or doesn't have one. Alright, next word is speed. Speed is the rate at which an object moves. Now, this depends on the distance traveled and the time taken to travel that distance. There's a picture of a golfer, and she's putting the little golf ball, and I don't think she has a mouth, so that's interesting. But anyway, the total time is 5 seconds. The total distance that the golf ball travels is 150 meters. So, you'd use the formula speed equals distance over time. So if we're going to calculate the speed of the golf ball, then you'd go speed equals the distance, which is 150 meters, over the time, which is 5 seconds. Now, you should know from math that you can reduce those. So, we're going to take 5 divided into 150, and you get 30. So the speed actually equals 30 meters per second. So the golf ball will travel 30 meters per second. Alright. Next word is average speed. The average speed occurs when objects don't travel in at a constant speed. Okay, so therefore we have to use the average speed. If you travel a distance of 5 kilometers and it takes you 10 minutes, you're probably not going to travel at a constant speed. You might get stopped by a stop sign. You might get stopped by a train. You may have to go to the store and stop at the store. And so you're going to find the average speed. Now, the average speed is the total distance over the total time. The way you find the total distance is you take the end distance, subtract the beginning distance, and you'll get your total distance. Time is the exact same way. You take the end time, subtract the beginning time, and you get the total time. So for this example, the average speed equals 5 kilometers over 10 minutes. So you've traveled 5 kilometers over a period of 10 minutes. Now, we know that we can reduce that, so it's going to actually end up being 0.5 kilometers per minute. So the average speed that the car traveled was a half a kilometer every minute. Don't forget to draw your pictures. Alright, here's some speed calculations. Write these down on a separate sheet of notebook paper and do your calculations. Number 1, if you walk for 3 hours and you travel 15 kilometers, what is your average speed? You might want to take a look back at your notes as to what the formula is for average speed. Now remember, at any time you can stop this video so that you can catch up. Number 2, if you run for 1.5 hours and you travel a distance of 7.5 kilometers, what is your average speed? And number 3, you drove in your car for 4 hours and traveled a total distance of 360 kilometers. What was your average speed? Alright, now we're back to the 4 squares. This time the word is velocity. We've already talked a little bit about velocity. Remember, don't get it confused with speed. Velocity is the speed of an object in a particular direction. So remember, velocity has to have a direction. Okay, there's always a reference direction. Those reference directions can be north, south, east, west, up, down, left, right. Those are all reference directions. Go ahead and draw you a picture. Remember, it's whatever is going to help you remember velocity. Now, here's an example. New York to Paris is 5,850 kilometers. The travel time is 12 hours. And the direction is northeast. So we'd use the formula velocity equals distance over time, which is your speed, plus direction. So to figure that out, it would be 5,850 kilometers over 12 hours plus the northeast direction would give you 487.5 kilometers per hour northeast. And that would be your velocity. Alright, here are a couple of velocity practice calculations. What is the velocity of a car that traveled a total of 75 kilometers north in 1.5 hours? Now the formula for velocity is up at the top. Number 2, what is the velocity of a plane that traveled 3,000 miles from New York to California in 5 hours? Now, I know one of the first things that some of you are going to say is there's not a direction in this word problem. Well, you have to think, what direction is New York from California? So if the plane is traveling from New York, which direction is it going to go to California? Alright, another four square, acceleration. Acceleration is the change in speed, the change in direction, or both. So it can be either speeding up or slowing down. A lot of times we see acceleration, we think of car, and when you hit the gas, then you accelerate, so you speed up. But it can also mean to slow down. So draw a picture. This one is a skier that's going downhill, and of course as they go downhill they speed up, and so they have an acceleration. Now you're not going to calculate acceleration this year, so you don't need to have the formula. Alright, now what you're going to do with these questions is you're going to think, did acceleration occur and why? Okay, you're going to write these on the exact same piece of paper that you did the others on. Number 1, you're riding your bike at 9 kilometers per hour. 10 minutes later, your speed is 6 kilometers per hour. Did acceleration occur? Number 2, you ride your bike around the block at a constant speed of 11 kilometers per hour. Did acceleration occur? And why? Number 3, you ride your bike in a straight line at a constant speed of 10 kilometers per hour. Did acceleration occur? And why? For number 1, acceleration did occur because you slowed down, you had a change in speed. Number 2, acceleration did occur because you weren't going in a straight line. You were turning, so you had a change of direction. And then number 3, there was no acceleration that occurred. And that is because you were going in a straight line at a constant speed. Your speed and your direction stayed the same. Alright, here's some review questions. These will go on that same exact piece of paper. Number 1, the motion of an object can be studied by observing the changes in an object's A, position, B, size, C, mass, or D, density. Question number 2. The best way to measure the motion of an ice skater is to compare the skater's position to the position of A, any other moving object, B, a slower skater, C, a faster skater, D, an object that does not move. If you chose letter A for the first question, you are correct. The answer for number 2 is D, an object that does not move. Questions 3 and 4. Suppose you can run 4 meters per second. 4 meters per second is your A, position, B, time, C, speed, D, distance. If you chose C, speed, you're correct. Number 4, suppose you ride a school bus that makes several stops and takes 1 hour to go a distance of 30 kilometers. The blank of the bus is 30 kilometers per hour. A, total speed, B, average speed, C, average time, or D, average distance. If you chose the letter B, you're correct. That is the average speed. Number 5. The average speed of a car that travels a distance of 240 kilometers in 3 hours is A, 720 kilometers per hour, B, 120 kilometers per hour, C, 80 kilometers per hour, or D, 40 kilometers per hour. Remember, the average speed is the total time over the total distance over the total time. So if you chose C, you're correct. 80 kilometers per hour. Number 6. A commuter train rounds a curve at a constant speed of 37 kilometers per hour. The train's velocity changes as the train travels around the curve because the train A, slows down, B, speeds up, C, goes at a constant speed, or D, changes direction. Correct answer is D, changes direction. Alright, we're finished with motion 4 squares.